This is exam 1 from fall 2019 for Calc 3. This is going to be a little bit of a wild ride, at least for me, because the last and only time I took this exam was as my exam 1. So it wasn't too bad. The average was higher than what they wanted, and so they really killed us on exam 2. But this is the first time for me going back and looking through this exam. So with that said, let's see how it goes. Let's find the equation of the plane through that point perpendicular to two planes. So all we're going to need to do here is take the cross product of the two normal vectors of these planes, and that will give us the normal vector of our third plane. And you can see this visually if we have some plane with a normal vector, and I actually won't draw the planes because it's more confusing if I do. We have one normal vector, a second normal vector, and then its cross products. And I hope you can see how the only plane perpendicular to both of these vectors is going to be, the plane spanned in between these. And this is also part of the definition of the cross product. It will give you, the area, this area here spanned between these two vectors, which is exactly the kind of plane that we're looking for. So let's pull out these factors. Sorry, by factors I mean normal vectors, and take a cross product. So we have 1, -1, 2, and 3, 0, 2. And crossing these, we will get -2, 4, 3. And we can set this up as a plane equation, -2x plus 4y plus 3z equals something. And we can see what it equals by plugging in a point that we know is on the plane. 0, 1, 2, that will give us 10. And we see that if we multiply everything in here by -1, or flip the side that each one of these components is on, we get answer choice B, which is correct. Let's identify this surface by completing the square. So really, all we have to do here is get rid of this 4x. We need to kind of absorb it into this 2x squared to see whether we get a positive or a negative constant, because with these completing the square questions, it's either going to be a hyperboloid of one sheet or a hyperboloid of two sheets. Those are really our options. So let's rearrange this. We have 2x squared minus 4x plus, minus, there we go, minus 2y squared plus 3z squared is equal to 0. And we can kind of, segment these a little bit. And also, it's good to remember that I'll leave x alone for now, but for y and z, these coefficients here aren't going to change what kind of quadratic surface we're working with. So those we can just remove. All that matters is whether or not they're squared and what kind of sign they have. So we can factor a 2 out of this expression right here. Come on, there we go. And we'll be left with 2x squared minus 2x. And then going through the whole process of completing the square, which I'm not going to fully show here, we will end up with 2x minus 1 squared minus 2. And then we can add the rest of our equation in, minus y squared plus z squared equals 0. And this -2 is going to end up over here. And since we know that coefficients really don't matter, and shifting along the x or y axes, or even the z axis, doesn't matter for what our shape is, we are left with an equation for a hyperboloid of one sheet, which is our correct answer. Yep, there we go. Okay, let's find the angle theta between the velocity and acceleration expressions at t equals 1 for this given position vector. So we can take some derivatives. V of t is going to be r prime of t, and that's just going to be the derivative of each one of these components with respect to t. So sine t, negative sine t, sorry, t, negative cosine t, and then a of t is going to be the derivative of v of t, which you can also think of as the second derivative of r of t, and that will give us negative cosine t 1 negative, oh, whoops, by negative sine t I mean positive sine t. And we are looking for, we're looking for the angle between these two vectors at t equals 1. So let's plug t equals 1 in here, but also we do have to know what kind of equation we're dealing with overall. And this just comes from the definition of the dot product, that theta, even though that looks like a capital Q, I tried, theta is equal to the inverse cosine of the dot product. In this case, it's going to be v dot A over magnitude V times magnitude A. Okay, so let's do this dot product. We are going to get, if we dot these two, cosine t sine t plus t minus cosine t sine t. So that's going to, and I should be specific here, this is v dot A. That's just going to leave us with v dot A equals t. And so we can go in here and replace our numerator with t, and we know that we're dealing with t equals 1. So we have 1 there. Now finally, magnitude v times magnitude A. Well, the magnitude of v is just going to be the square root of sine squared t plus t squared plus cosine squared t. So let's write that out. Sine squared t plus cosine squared t plus t squared, where all of this will simplify down to 1. There we go. Okay, so we're left with the square root of 1 plus t squared, and this is for magnitude v of t. For magnitude A of t, we are going to get exactly the same thing. We're going to end up with a cosine squared, a sine squared, that'll become 1, and a 1 squared. So, sorry, it's not exactly the same thing, but you'll see in just a second. They are really the same thing because this t squared is the equivalent of 1 squared. So this whole thing can simplify down to root 2. Root 2. So now we have root 2 times root 2, and so our denominator is just 2. And the inverse cosine of 1/2 is pi over 3. Let's compute the curvature of this curve for t equals pi over 4. The equation that I like to use for this, k, they always make it a little curly k, and I can't do it very well, is bad magnitude bar. Nope, I want that. There we go. The equation for this that I like to use is v of t cross a of t magnitude divided by magnitude v of t cubed. And so this just involves us finding v of t and a of t, where v of t is just the derivative of r of t. That's going to give us 2 cosine t, 0, negative 2 sine t, and a of t will be negative 2 sine t, 0, negative 2 cosine t. So our cross product here is going to be, let's see, we're not magnituding yet. A of t cross v of t, well, sorry. I gotta be correct here. Really, we're doing v of t cross a of t because the way we have it set up, but either one will give us the same answer because we're taking the magnitude. Blah, blah, blah. Okay, this cross product is going to give us 0, comma, negative 4 cosine squared t minus 4 sine squared t, 0. And this whole thing will simplify down to negative 4. So there's our cross product. We're taking the magnitude of that. The magnitude of 0, negative 4, 0 is just going to give us 4. And so we get 4 on top there. And then the magnitude of v of t cubed, well, the magnitude of v of t is going to be magnitude v of t will just be the square root of 4 cosine squared t plus 4 sine squared t. That's just root 4 or 2. 2 cubed will be 8. So 4 over 8, our answer is 1/2 for question 4. Question 5, let's find the length of the curve given there is r of t for t between 0 and 2 pi. So we're integrating from 0 to 2 pi of the magnitude of r prime of t dt. That's just our equation for arc length. And let's find our r prime of t. This is going to be negative cosine t. Oh no, yeah, this one's not that fun. Negative cosine t, and by negative I mean, okay, let's start that over. Cosine t minus cosine t plus t sine t, and then negative sine t plus sine t plus t cosine t. Okay, and this simplifies r prime of t. This cosine t will cancel with this negative cosine t, and these sines will also cancel. We're left with t sine t, t cosine t. The magnitude of that is going to be the square root of t squared sine squared t plus t squared cosine squared t. That will simplify down to the square root of t squared, or just t. So we are left with this integral that's a lot less scary than anything that we had before. And when we evaluate this, we will get t squared over 2 on 0 to 2 pi, which will be 4 over 2 pi squared. So 2 pi squared, which is answer choice C. Okay, everyone was pretty confused by this question because it's effectively a Physics 172 question. Not really sure why it's coming up here, but let's give it a go. A small metal ball thrown vertically upward with a speed rises to a maximum height, then falls and strikes the ground. How high does the ball rise from its point of release? And gravitational acceleration is 9.8 meters per second squared. So all this is really telling us is that A of t is 0, negative 9.8, 0. We can find v of t because we know that v of 0, so initial velocity, it has an initial y component of 19.6. So 0, 19.6, 0. And so here we're going to get negative 9.8 t plus 19.6, comma, 0. And this is just what we do for these particle motion questions. Whenever we integrate all these components to get from A to V to R, we have to make sure that we adjust our components for the constants given in our V0 and R0. So this guy's our V of t. Now we can integrate one more time to find R of t. R of t will just be 0, negative 4.9 t squared plus 19.6 t. And let's see, we are starting from the ground, aren't we? Rise to a maximum height, then falls. Okay, it does not matter where we start. All we care about is how high the ball rises from its point of release. So we're going to say that that point of release, R0, is just 0, 0, 0. It simplifies things a little bit. And so there is our R of t, and all we have to figure out is what is R of t when t is halfway between the, so I can draw this out and it'll be a little bit more clear. We have thrown our ball up, and really our ball doesn't have any x component of velocity, but it's easier to draw it this way. We want to find this time, given that the total length of time taken is some value t. We're looking for the R of t at this point, which will be t over 2. So we can easily find that by realizing that this is going to be the point where the y value of v of t is 0. Whoops. And so we can take this y value and extract it out and say that negative 9.8 t plus 19.6, that's 16.6, whoops, 19.6 has to be equal to 0 at this point here. And we will solve this and see that t equals 19.6 over 9.8, and this is just t equals 2. So at t equals 2, we're at the top of our arc up here, and from this we know that it would take 4 seconds to hit the ground, but that doesn't particularly matter to us, and we can just take this t equals 2 and plug it into our R of t. So R, and it's not R of t now, it's R of 2, if I can get that to work. R of 2 is 0, negative 4.9 times t squared, so negative 4.9 times 4. Well, that's just going to be negative 19.6, and then we're adding 19.6 times 2, so, comma 0, and it's looking like we're going to reach a maximum height of 19.6 meters. You can take some little shortcuts in this if you recognize that this acceleration here means that every second we are going to lose 9.8 meters per second of velocity. And from that, it's very easy to see how, after 2 seconds, we're going to have a velocity of 0. And all you have to do from there is just form R of t and plug in 2 for that. So overall, not a bad question, but very weird for what they have asked in the past. Okay, this one stumped a lot of people when it really shouldn't have. So assuming that this limit exists, what's its value? There's a fact about limits that you should know. It's that the limit as x approaches 0 of sine x over x is 1. And you can find this through L'Hopital's rule. And in fact, you can end up doing some L'Hopital's rule shenanigans on this guy up here, but all you need to recognize is that the value in here for sine is 4 times the value that I shouldn't be saying value. The expression up here is 4 times our denominator. It's exactly 4 times. And this guy holds. So if we have the limit as x approaches 0 of sine 4x over x, that is equal to 4. And we can see this through L'Hopital's rule. In fact, we can just do it right now. If we take the derivative of the top and the bottom, we are going to get 4 cosine 4x over 1. And when x approaches 0, this whole thing approaches 4. And so really what you could do in here is substitute x squared plus 2y squared as some I don't know, some value, you can call that z, and this whole thing will just become the limit as z approaches 0, and this isn't fully rigorous, but it does work for this question. The limit as z approaches 0 of sine 4z over z, and whenever you see something like this, you know that you can just use the fact that sine z over z as z approaches 0 is equal to 1. So overall, this whole thing is equal to 4. Question 8, if we have some function of x and y, that's this whole thing, we're looking for the second partial derivative of this. And by second, I mean second order mixed partial derivative, so fxy. And again, with all these, Clairaut's theorem, pretty sure it is, says that you can also find fyx at 2, 1, and since this is a, I think the adjective is nice function, something like that. It's been a while. These will be the same. So if you really feel like, going off on your own and doing fyx, go for it. And it might be good practice, good way to get double the partial differentiation practice in the same number of questions. But whatever, let's do fx to start things off. That's going to be 2x over x squared plus y to the fourth plus 2, and fxy is going to be negative 2x over x squared plus y to the fourth plus 2 squared times 4y cubed. And we're plugging in 2 and 1 in for that. So we have negative 4 times 4, so negative 16 divided by x squared, so 4, 8, 10 squared. Is that right? No, sorry, 4, 5, 6, 7. 7 squared, so 49. And we're left with negative 16 over 49, which is answer choice D. And if you've clicked this question to remind yourself what partial differentiation is, I always forget that this is a thing that some people, all I'm doing when I'm taking a partial derivative for taking fx is we are holding all of these y's constant, thinking of them as constants, and taking this derivative only with respect to x. Question 9, we have some function f of xy, and we're looking for the direction of steepest descent. If you get a gradient question like this, circle whether it's descent or ascent, because it might seem crazy to you now, but a lot of people in the exam that I know afterwards were like, oh no, I read ascent, or I solved for ascent when I knew it was descent, and that little wording can really trip you up, because we know that if we're looking for the direction of steepest ascent at a point, that's going to be the vector fx, fy, but if we're looking for descent, that's the opposite, negative fx, negative fy. So let's do that. Let's find fx and fy. Fx is going to be y e to the xy plus xy squared e to the xy, whereas fy is going to be x e to the xy plus x squared y e to the xy. And we are looking at the point 2, 3, so we'll plug that in. We'll get 3 e to the 6 plus 18 e to the 6, and over here 2 e to the 6 plus 12 e to the 6. And so we have a lot of common factors here that we can get rid of, and our answer will be equivalent, notably all of these e to the 6's, because really we're looking for a direction vector. We do not care how long our vector is in any way. So we can get rid of all these, e to the 6's and add these guys up. So we are left with fx equals 21, fy equals 14. We can divide all these by 7, and we will see that this is proportional to the vector, let's see, 3, 2. But we know that we're looking for steepest descent, so it's not 3, 2 that's our answer. Our answer is -3, -2, which is answer choice A. Let's consider this function on all of R2 among its critical points. It has what? This question was by far the most controversial question, going over the answers afterwards, talking with people. This one tripped up the most people, and for good reason, because it's a really kind of rude second derivative test question. So hopefully this isn't the first time you've seen me do this spiel, but I do it the same way every single time for these questions. When we're doing the second derivative test, we have a matrix with fxx, fxy, fyx, and fyy. These positions are A, B, C, D. We are taking the discriminant of this matrix, where the discriminant is AD minus BC, and if that is greater than 0, and fxx is greater than 0, we have a min. If fxx is less than 0, we have a max. If the discriminant is equal to 0, we don't know anything. And if the discriminant is, less than 0, we have a saddle point, no matter what the entries in our matrix are. So taking these rules, making them small, putting them up here, we'll reference those in a bit. First, we have to find our critical points. We know that critical points exist where both fx and fy are equal to 0. So let's figure out what fx and fy are in the first place. We have y to the 4th minus 1 minus x, and we have got 4xy cubed. Yeah, and that's it. So taking a look at fx and fy, we see that given fy down here, always either one or both of our x's and y's must be equal to 0. So judging by that, we see that 0, 0 does satisfy fy, but it does not satisfy fx, because if we plug 0, 0 into fx, we get -1. So 0, 0 does not work, but some of these other points might. So 1, 0, -1, 0, 0, 1, and 0, -1 are all candidates. But let's make sure first that all of these satisfy both fx and fy. Well, 1, 0 satisfies fy. In fact, all of these do, but it does not satisfy fx because it will give us a value of -2. So that one's out. On the other hand, this guy right here is good. It will make fy be equal to 0, and also fx equal to 0 as well. And then continuing down the list, both of these are also going to work, because our y value to the 4th power -1 minus 0 is always going to be 0. So these are our 3 points to check through. Now it'll be a good idea to set up our matrix. So fxx is going to be -1. fxy will be 4y cubed, and so will fyx. And then fyy is going to be 12xy squared. And so with these 3 options, we can set up 3 different matrices corresponding with each of them. For -1, 0, we're going to get -1, 0, 0, and 0. For 0, 1, we'll get -1, 4, 4, 0. And over here, we will get -1, -4, -4, 0. Okay, so what did we say? If our discriminant is equal to 0, we know nothing about whether or not it's a maximum, minimum, or saddle point. So over here, if we apply the discriminant AD minus BC, we will get 0. So this guy means nothing for us. This one is not going to be part of any of our answer choices since we don't know anything about it. But otherwise, over here, you will get a negative discriminant, so D less than 0, D less than 0 for both of these guys, which means that we have 2 saddle points. This was a very kind of crappy function for them to choose for this, because if you graph it, like I did after the exam, you'll see that this function kind of does have a local maximum, but it's a really kind of sneaky way where the function along one axis kind of reaches a plateau and stays along that maximum value with respect to one axis. And so some people found that kind of plateau and labeled it as a maximum. So they actually accepted E as a correct answer as well. But I'd be really careful with that. Stick with what the math tells you, and you will be okay. Let's consider this function on this rectangular domain. First, let's figure out what they even want with this rectangular domain. Well, they're saying that x runs between -2 and 2, and y runs between -1 and 1. So I can actually make this look a lot better. Here we go. Got one axis, another axis. Okay, so x runs from -2 to 2, y runs from -1 to 1. So our box is going to look something like this. So this is the domain of values that we get to choose from. And we see that we are trying to figure out a fact about this function d on this domain. It's important to look at really what this function is doing. This is a distance formula when it comes down to it. And we're finding the distance away from the point 2, 2, and you can kind of pull that out of here. X equals 2, y equals 2 solves that equation. So 2, 2 is going to be sitting right up here. Okay, and so just to clarify, it does have a +4 in here, which is really not part of the distance function, but this will still behave like a normal distance function, whereas we get farther away from the point, the value of d will increase. All it means is that this function cannot be less than 4. If we were sitting right on top of the point there, we would still have a value of 4 under our square root. Okay, let's take a look at these answer choices. It has a local maximum at 0, 0. Well, no, not really, because if we're at 0, 0, we can make this distance function grow just by moving away. So this does not make sense. It has an absolute maximum value of 5 and an absolute minimum value of 2. Well, if we look at this graphically, the closest point to 2, 2 is going to be right here, and the farthest point is going to be right here. This is the point 2, 1, and this is the point -2, -1. If we plug in 2, 1 to this distance function, we're going to get the square root of 2 minus 2 squared, so 0 plus 1 minus 2 squared, which is 1 plus 4. Nope. So this is also wrong, because our minimum value on this domain is actually root 5, not 4, which would be root 2. So B is also out of here. If I can get rid of all of that. There we go. Okay, C, it has a local minimum with a value of 2. Well, no, it doesn't. We just established that the lowest we can possibly get with this is going to be on this little corner here, and that's going to be root 5. So there's no local minimum sitting anywhere in here that would satisfy that. that value of 2. Is it a linear function? We'll come back. We'll come back to that. Let's look at E. Does it have an absolute minimum value of root 5? Yep. Well, we saw that. And well, we forgot to, but let's compute what its maximum value would be over here at -2, -1. That will give us root -4 squared, so 16, plus -3 squared, so 9, plus 4. And that is going to be 25, 29. So root 29 is our absolute maximum value. And this is our correct answer. This is not this is not a linear function at all. And that is it. This exam, when I took it, went well for me. I think if you prepared with the past exams, this one would have been a pretty, standard one. It was exam 2 last semester where things got bad. So you don't want to really get an exam that's this easy. You want one that's hard enough so that they make exam 2 a little easier for you, because they can really make exam 2 hurt. But hey, you're not there yet. You don't have to really worry about it. But yeah, thanks for sticking around.